If I stopped someone in the street and asked them what these were, they'd probably just say a collection of numbers and letters. And they might even know that they are equations, but that's all they'd know. But since you're studying maths, they should certainly mean something to you. The first is a quadratic, and the second is a linear or straight line equation. And in both cases, you should have a good idea of their basic shape. The second thing you need to be able to do is plot a graph. And I'll give you a quick reminder by plotting this quadratic. Always start with your table of values. Decide what values of x you're interested in, and this will usually be dictated by the axes that you're using. And since my graph paper here has -5 through to 0, they are the values of x that I'll be using. Now you can think of your equation as a rule that tells you what to do with your value of x in order to find y. And this rule tells me to square x, then add 6 lots of x to it before finally adding 11. And on a non-calculator paper, you'll always use substitution followed by bidmus. Substitution is always the same wherever you see the symbol that you are substituting, brackets. And if you employ this method, you are much less likely to go wrong. And then substitute in the value that you're evaluating. That's it, substitution done, very easy if you employ this method. Now we're going to use bidmus. Brackets, well there are brackets, but there's nothing to be done inside the brackets. We move on to the index. Well, yes, we've got here -5 squared, so 25. We've got no division, but we have got a multiplication here because of this here. And there we have it. Just to make life easy for myself, rather than adding 1 minute, subtracting the next, I'll move it around like this. And on a non-calculator paper, it's very important that you employ strategies that mean it's less likely that you're going to go wrong, and this is one of them. Get the additions next to each other. Get that out of the way first. 25 plus 11, 36, minus 30 gives me 6. Very straightforward, but will help you avoid errors. On a calculator paper, use your calculator like this. And now that I have a completed table of values, I can read off each coordinate and plot it. So here I can see that the coordinate this represents is -5, 6, and so I'll plot this, and so on. And using my knowledge of what a quadratic looks like, I'll plot the curve. And we're done. Now I'm going to show you a method that we can use to solve an equation like this graphically. It's not the only way, but it can often be useful, and you need to know it for the exam. And the crucial point is how you view this equation. You look at it as two separate equations, one on the left and one on the right. We have one on the left and one on the right. And I plot them. The one on the left, the one on the right. And where they intersect, in other words, where they are equal, is the solution to the original equation. Now the unknown is x, so it's x that I'm interested in, and we can see that they intersect when x is -3 and x is -2. So these are the solutions. We can view this in just the same way. we view it as two separate equations, one on the left of the equal sign, one on the right of the equal sign. I plot the one on the left and the one on the right. And where they intersect is the solution to the original equation. So here we have x is minus 4 and x is minus 1. So here's a typical exam question, and you know just what to do. Part A, we plot the graph. Part B may have caused you some problems before you watch this video, but we can see it as two separate graphs. One on the left, one on the right. And it's no coincidence that part A of the question got you to plot this already in advance. So now you've plotted this graph, you just need to do the other. And finally we can see where the graphs intersect, and this is the solution to the equation. Remember, with our original equation, the unknown is x, so it's x that we're interested in, and x is minus 6 and x is 0. Now, just one quick point. The truth is you won't normally use the graphical method unless you're told to use it or it's clear that the question wants you to use it. Why would you bother? Messing around, sharpening a pencil, trying to find a ruler, graph paper and so on. Normally you'll just use algebra. So when you see a question like this, I recognise that it's a quadratic, and like any quadratic I want to solve, I need this to be equal to 0. How do I deal with this nuisance plus 3? What I'll do is I'll subtract 3 from both sides. So now I've got it in a form that I can solve. I'll either use the quadratic formula or complete the square. However, if I know for certain that it's going to factorise, I can use that method. And that's the case here. I can see it's going to factorise very easily. And finally I have my solutions, either x equals 0 or x equals minus 6. Done.